So the human hand, can everyone hear me? Yep. The human hand is a really remarkable and versatile tool for interacting with the physical world. I can close my eyes and pick up a glass of water because I can feel the weight, I can feel the slipperiness of the surface, and I can feel where the center of mass is. Tactile sensation is what enables our extraordinary dexterity. And there are a number of jobs out there that exploit this dexterity, but unfortunately we're suffering from labour shortages and our population is ageing. And in a lot of circumstances, we're asking people to do jobs that are just outright dangerous. And this is an existing and worsening problem that needs a solution right now. And what is that solution? Robotics. But, there's always a but, robots that do meaningful work for us require extensive and expensive customization to perform seemingly simple tasks. And there are no current gripping technologies that come anywhere close to achieving human dexterity. And this is because robots can't feel what they're touching. So tactile sensing is the final frontier for solving robotic dexterity. My name is Heba, and I'm a co-founder at Contactile, and we've developed the technology that gives robots a human sense of touch. Our patented soft-sensored design is as sensitive as human skin, and it enables intelligent, dexterous gripping. The robotics market, as you can imagine, is growing, and it's expected to reach $87 billion by 2025, with robotic end effectors, that's the hands of the robot, having a $5.7 billion share. Our minimum total addressable market is the $1 billion gripper portion of that robotic end effector market. But there are markets beyond robotics, and tactile sensing is used in other industries such as automotive and mining, so we can attack that too. There are a relatively small number of robotics component manufacturers, and Contactile is one of those. We will sell to the 4,500 robotics integrators who want to minimize the time and effort required to build custom automation solutions for their customers. We'll also sell to the 5,000 research and education institutions where researchers want tactile sensing technologies that they can integrate into the next generation of robotic solutions. Our customers are located all over the world, and we've been thinking global from day one. We've already connected with robotics integrators and researchers in Australia, Ireland, the UK, the US, and Canada. And we've connected with robotics manufacturers in Germany and Japan. Our tactile sensor array measures all the tactile parameters that are essential for robotic dexterity and can be easily integrated with existing robotic grippers. The sensor is completely customizable and modular. It has excellent environmental compatibility and can be easily repaired if the silicon skin is damaged. Our intelligent sensorized gripper has the sensor integration and control system already implemented, and the gripper can apply optimal grip forces to any object. It's versatile, plug and play, and collaborative. There are no other sensors on the market that can measure all the sensing modalities that our sensor can. And these are all required for dexterous manipulation. In particular, the robustness, easy integration and maintenance, incipient slip measurement and friction measurement are highly valued by our customers. The intelligent sensorized gripper also ticks all the boxes. The value add here is in the dexterity, no need for pre-programming or additional input parameters, and the competitive price. We have a three-pronged approach to go-to-market. We've already secured sales with our early adopters in universities and research institutes. We're currently negotiating evaluation projects with large multinational robotics manufacturers so that our technology can be shipped with their products. And we will continue to perform R&D and product development, retaining our competitive advantage as one of the leading tactile sensor companies. The co-founders are a team of very talented, if I do say so myself, engineers who've been working together for between 4 and 6 years with a combined 15 years experience in tactile sensing and robotics. And though we've only started our commercialization journey this February, We will be shipping out to our first international customer next month.
Thank you, Heba. That is time. And now you have 3 minutes question time.
I thought that was really impressive because robots need
Robots are cool.
robots need to be
Job done.
tactile, right? For so many reasons. I was wondering, what is with your approach to solving this problem, which clearly there's been many other technology companies that have tried to tackle this before. What's happened? What have you done to nail it? And what's sort of been the breakthrough?
So the technologies that you speak of are usually based in vision. And as I mentioned, I can close my eyes and still pick something up. But if you actually take away someone's sense of touch and they can still use their vision, dexterous tasks become much more complicated. And so the technologies that are currently available are asking robots to perform dexterous tasks using only vision. So vision can take us part of the way, but not all the way. And any tactile sensing technologies that are currently available only tell the robot how hard it is gripping, but not how hard it needs to be gripping. So there's that gap there of knowing that, I have an object safely in my grasp, or I know I'm applying this much force, but not knowing whether it's dropped or you've still got it.
Do you use vision?
No, so it's an array of 3D force sensors, and it uses an optical method for sensing.
Suggestion and a question.
Yep.
The suggestion is open up with your bio. You spent 3 minutes, you got to the end, and I kind of knew who you were, so I was already paying attention, but you're one of the most credible founders that stood up here today, but we had to wait 3 minutes to hear that. So start with that, and then everyone will pay attention.
Sure.
The question is around the applications for this. Like, it sort of feels intuitively obvious that you would want tactile sensing grippers, but then you show a picture of a gripper on a Fiji water bottle, where I wouldn't have thought it would matter that much.
No, that's right. So that's actually part of a multi-step video, but so that video is actually showing you that it can grip that bottle with the right amount of force, and even if you increase the weight of the bottle by pushing down on it, it will adapt the grip to that. But you're right, there are obviously more pressing applications than picking up a bottle, which we can already do. And that is in fruit picking, in any kind of food packaging environment where, every piece of fruit is different. And also in warehouse order picking as well, where you've got Amazon warehouse with millions of products. You couldn't possibly pre-program a gripper to be able to grip every single product. So this is where that kind of applies.
Yeah, that makes sense. And by saying more pressing applications, you also win pun of the day.
Yay.
20-second speed question.
No. Thank you very much.
Fabulous.